Now we're doing applications, so we can talk about Pythagorean theorem and how to make it useful with only one side. Theorem. So as you recall, c squared equals a squared plus b squared is going to be our equation. And then I'm going to go back to using our example of our laser eye shooter guy. So basically, we want to figure out where the lasers are going to stop because we want the lasers to strictly stop at like the grass or the ground, right? So we have our little guy here and we want it to stop at the ground. So how do we do that? We use triangles, as we said. So we can model this after a triangle. So this is our beam. We want to figure out this, our side C, or laser beam side. We don't know what it's equal to. But there's one other stipulation. If this point is always changing, what do we do? Our only known side is our player height. This is all we know. This is the only thing that's consistent. So what do we do? Great question. So we can actually gather the angle that the player is looking rather than the point that's always changing. It's much easier to figure out the angle of the player's point of view rather than the point that's here, because think about it, this triangle is going to change a bunch in size and shape, but this height is going to remain consistent, and wherever the player is looking will remain consistent. So instead of trying to figure out and always look for this endpoint, it's just not easy, it's not nice to do. So what we can do is we can say, okay, I want to get this random angle theta that this player is looking at. Now what? Where do we go from here? So right now we have theta and we have h, height. Those are the two things that we have. So now we can use some other trig rules. So we have tangent theta, which is equal to adjacent over opposite. Then we have sine theta, which is equal to opposite over our hypotenuse. And then we have cosine theta, which is equal to adjacent over hypotenuse. So we have a few options that we can take to go ahead and do this. So our first option is using Pythagorean theorem, which I'm going to demonstrate. So we already have our angle. We can just take the tangent of our angle and we have a side. So now we have to figure out what is adjacent and what is opposite. So adjacent is going to be the side that's next to our angle. So as we can see here, our adjacent side is going to be the height. And then we have our opposite side. The hypotenuse is always going to be our longest side. So we're never touching the longest side unless it says hypotenuse. So this is going to be our unknown. So that is our opposite side. So we have h over up. And then we have our equation to solve. So this is our unknown. Basically, what I'm going to do here is I'm just going to do tangent theta, and I'm just going to divide out by our h equals 1 over up. And then I'm going to take the reciprocal of all, so h over tangent theta equals our opposite side. So then we could plug it back into our equation here and do c squared equals height squared plus op squared. So that's one of our options. Then we can take the square root and do all that good stuff. So our next option is we can use one of the other trig formulas and do this a different way. So we can simply just solve for our hypotenuse using our trig formulas. So which one do you think we should choose? Which one do we have that is known? So we have, our options are tangent, which we just saw, and then we have sine, which is opposite, or we have cosine, which is adjacent. We know our adjacent side, so we're going to go with cosine. So we're going to do cosine theta equals height over hypotenuse. right? So then we can solve for this. So then we have cosine theta all over h equals 1 over hypotenuse. Then we can take the reciprocal and just have h over cosine equals our hypotenuse. So then we can figure out the exact distance to shoot our lasers.